So we started off with this code. And to try to make it loop, we added a while true. A while true sets up an infinite loop, unless there's a break statement later on to get out of it. And then I indented those 4 lines. So now when I run it, it should go forever. Is this an optimal solution? No. We really want the user to be able to get out without just killing the program. Unlike an app that you put on your phone. But anyways, enter a number, 20. It prints out 40. Enter a number, 40. It prints out 80. Negative 100, negative 200. Okay. When I'm ready to stop it, just click the X in the shell window.
When I run mine, I just get the number that I put in. I don't get the number times 2.
It could be, let me come look.
I don't see my error.
Okay. So what we really want is a way to break out of this that doesn't involve just clicking the X box. We want to let the user stop the program. There's typically 2 ways that people do that kind of thing. You could do you wish to run again? That kind of thing. That's called stopping by user query. Or you could do something like this. Please enter a number or -1 to quit or 0 to quit or something like that. That's called using a Sentinel value. You know what a Sentinel is. It's the guy who sits there and guards the castle or whatever. The Sentinel value only lets the code keep running as long as the value does not match a certain specific input. There's a special input that will cause it to stop looping. And you want that input to not be valid data. You know, if you were writing a bowling scoring program and you wanted to say, you wanted to let them stop entering their data early, it'd be a bad idea to make 0 your stop value, because that would stop the game the second you struck out, rather than letting you continue playing. Instead, you'd want to use -1 or -999 or something like that. So we're going to use the Sentinel approach because it's easier to modify our code in our flowchart to match that idea. So what I'm going to do is I'm going to modify this, not to just while true, which means run forever, but it's going to have a condition in it. While my number not equals 0. Now to get that to work, I'm going to have to make a couple of other changes. I'm just going to show you the next slide. You can't do a while or an if on a variable that doesn't already exist. So I have to initialize this variable with a value. Because otherwise I can't do if my number is equal to 7 if I haven't already got a value in my number. That'll be a syntax error. So I have to set this equal to value that's not going to cause it to exit the loop. So this is a valid value. Then, as long as my number does not equal 0, input my number. If my number not equal to 0, then we double it. And then we output my answer. This is wrong. This should actually be under there. I made a mistake when drawing this. I'm going to show you the flowcharting program that I use. Y'all will be using it too before long. It's called Lucid Chart.
We don't use Visio here?
You can use Visio if you want. I'm totally not against you using Visio. This is a multi-platform one, so I encourage people to use it because it works on Linux or Mac or whatever. So you log in. You will log in with your rose.edu address. Don't try it yet because your accounts aren't set up. We will do that pretty soon. You will do that pretty soon. Let me find my most recent document. There it is. Yeah, Visio is Microsoft's flowcharting program, and it's perfectly good. One quirk about Lucid Chart is that, at least as of last semester, you could not use Firefox in order to access it. You had to use Chrome or IE. Okay, so what's wrong with this logic as is? Before I tell you what's wrong with the logic, I kind of gave you a hint when I said I'd move the box, but what's wrong with it?
Doesn't the arrow need to point straight down to the circle? The circle needs to go to the right below that.
Yeah, you could modify the placement of things and have the arrows go slightly differently, but that's not going to change the logic of it. That's a presentation. And I'm happy enough with the boxes where they are. What is wrong with this is that what happens if they do type in 0? Input my number. It skips this thing. It doesn't double the number, but then it goes ahead and it tries to print it anyways. Why print double 0? If 0 was supposed to be our clue that we wanted to leave, then we don't want to print any results from that. So we need to push that over here.
That's never going to be a scenario because previous in your flowchart you're pulling out all the zeros.
Sort of. I sort of agree, but don't really. I'll explain why in a minute.
How could you have a 0 if you're pulling them out with the first decision?
I'm going to have to delete some lines. Okay. Really? Alrighty. Close enough. Okay, the reason why it can equal 0 is the while loop doesn't have magical powers to immediately kick us out of the loop as soon as this thing turns 0. It only gets checked when it hits this box again. So what we're going to do is we're going to let them type a number in. If the number is not equal to 0, see, we don't go back and check immediately after we input the number. The next thing that happens is we do this if.
Yeah, but in the whole flowchart it says, what is my number? And then it says, while my number's not equal to 0,
right,
yes,
but
go this direction.
This does not
input the same number.
This does not let them, this doesn't suck it out of the processing though. My number doesn't equal 0 before you get to that while. It equals 1.
Right.
We've initialized it to a value. So programming wise, it's going to execute that line, it's going to execute that line, it's going to execute that line and let them type it in.
If it were 0, it would go down the no arrow.
It would.
There'd be no way to put a 0.
It would, but we don't know what number it is yet. So we let them type it in, and now we have a number that we can evaluate. If it is 0, well, if it's not equal to 0, we process it, we display it. If it is 0, we go down to no, and it loops back up here, and now it checks it again. While my number not equal to 0. If it equaled 0, because we typed in 0, and then it falls through. We'll see it when we do it in the code. And this one, you're going to have to take it on faith for a few minutes, because it's correct. So, going back to our code, let's say x is equal to 1. Again, I just chose x rather than my number because it was shorter. And modify your while statement to say while x not equal 0. That's what the exclamation mark is. Whenever you look at code and you see an exclamation mark, just say not. It's shorter to say not than exclamation mark. Programmers have come up with silly names for the exclamation mark over the years. Like some people call it bang. Nah, I'm not going to call it bang. Okay, so then we ask them to enter a number. So after the input statement, still tabbed over, I'm going to do this. If x not equal to 0, colon. And then I'm going to push those two lines over one level of indentation. Nope, 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 that's not good logic. This needed to be in a different place. Please excuse me. Remove that if statement and put it beneath the x is equal to int x. If x not equal to 0, colon, then these two lines need to be indented. And for good measure, we're just going to put a done down here at the bottom, a print done statement, because it looks kind of weird having all this indented stuff with nothing left underneath it. So maybe you see what I mean now. X is equal to 1. This is not equal to 0, so it goes ahead and executes. The next thing that it does is let you type in a number. Then it converts it to 0. Then it checks. If it's still not equal to 0, we go ahead and double it and we print it out. Then we come back and the while loop is checked again. The next time through, they type in a 0. So after the conversion, we do this check. This is not true, so nothing happens. We come down here, and then when the end of indentation is hit, it comes back up to the while loop, it checks, and it goes, oh man, X is equal to 0 now, so that's effectively our no line. It stretches down from there. Let me know if you get a syntax error when you run this. I should have checked it before I started talking too much. Make sure it worked. Enter a number, 100, enter a number, 200, enter number 0. Okay. So I managed to get the logic right. Pat myself on the back. Pause it and wander around. The user didn't really know that typing in a 0 was going to cause it to stop. So if you are going to use a Sentinel value, you probably ought to do something like this. Or 0 to quit. Something like that. Maybe the user is really curious as to what double 0 is, you know? Maybe they haven't learned that 0 times something is 0. So they're going to try it out. Okay, now that we've done it this way, I want to illustrate using a user query instead, where you ask, do you want to run again? So, just copy all of these lines. And paste them so that we have 2 copies of the code. But we're going to make a few changes. This line that says X is equal to 0, I'm going to change that to R equals no. So this line changed. This line's going to change a little bit. We're going to make it while R not equal no. Like that. And what we found out is that although spaces can be added or removed, usually if you separate those two things, that fails. So yeah, these spaces are optional. They don't hurt the program. If you put one there, it would have broke it. Okay, so this line changed. This is going to change a little bit because they're not going to type 0 to quit. Delete all of that stuff we just added. Enter a number.
Do we need to put in the pound changed?
You don't have to do those. I'm doing those to let you know which lines are changing because not everybody types at the same rate. Yeah. My little comments, you don't have to type those. All right, we're going to nuke. We're going to delete that if statement because we no longer care if it's 0 or not. So I highlight that. What I do is I put my cursor at the top or at the beginning of the line. I hold Shift key and then use the cursor down to get the entire line. Of course, there's lots of ways to delete things. I tend to keep my hands on the keyboard as much as possible rather than use the mouse, but I know most people use the mouse. Now, it's a syntax error for this stuff to be indented. The only time we can indent is after a colon like that. So I got to unindent these guys. You can either unindent them by hand or you can highlight them both and go to Format, and then it uses the funny word dedent. It's really about the only time I've ever seen the word dedent. I just do it by hand, usually, unless it's a lot of lines of code. Okay, now we need to ask the user if they wish to continue. So really, that line changed too. Then we deleted a line. Don't have to add these comments. These two lines got unindented. Next, we're going to ask them whether to continue or not. Do you wish to continue? Yes, no. That top line that says R is equal to no should be R is equal to yes. I'm going to go back and change these top two lines. So this changed again. Sorry about that. And this changed again. What are we going to do? We're going to say R is equal to yes, and then while R equals yes. If you can avoid using not equal, it's easier for the brain to process. The computer doesn't care if something is a not equal or an equal. I mean, the logic has to be correct. But when we're reading it, it's easier to understand while R equals yes rather than while R not equal no. Okay, it's possible this is going to work. Enter a number, 0 to exit. This is the first loop. 10, 20, 0, that stops it. Now we're in a second loop. The second loop isn't asking whether, 0 to exit or not. So I could type the 0 in and it would print out that 0 doubled is 0. Do you wish to continue? This is what's new. Do I wish to continue? Yes. Enter a number, 9. Do I wish to continue? Yes. Enter number 20. Do you wish to continue? No. Then we stop. So this top one is an example. I'm going to add a comment to it. Looping with Sentinel value. Took me a while to memorize Sentinel. I always wanted to put an A at the end, but that's not correct. The bottom one is an example of looping with user query to terminate. It's a lot of writing. Okay, before I delete these comments, if you have yours working and you put those comments there, you can remove them. I'm going to remove them in a minute, as soon as I make sure everybody's got it working. The only time where you can type in yes or no is when it's actually down at this point. If you type it in anywhere else, it's going to generate an error, which isn't great programming. If the user types in garbage, we ought to handle it gracefully. But we're not there yet. So, there's a couple of places where I could type in yes or no and it wouldn't work at all. Enter a number. No, I don't want to. Okay, well, it blows up there. But you probably weren't expecting that to be where you could type it. Let's run it again. Enter a number. Here's another one. Enter a number. Alrighty, 9. Do you wish to continue? Yes or no? Yes. Enter a number. Now I change my mind. No. It blows up there. The reason why is this input is the only one where it's safe to enter yes or no. Why? Because if you type in yes or no at this input, the very next line is trying to turn it into a number. You can't change yes or no into a number. Same thing here. Enter a number. If you type in anything other than a number here, in fact anything that's not a whole number, it's going to blow up. It will blow up on that line when it tries to convert it. If we want this code to support floating point numbers, we just change that int to the word float. What do I mean by that? If I run it, and I think that I ought to be able to enter 3.14, well, the program doesn't think so. So let's change it to support floating points. Just go back in, and in those two places where we have the word int, where's my printer? Oh, there it is. Okay. If you ever get behind and you want me to print the code out, I will do that. Okay. There we go. We could put a line in between this and this one that would double check to make sure that they had typed in a valid number, that it wasn't a word. But we've already made this pretty complicated. We're not going to make it more so. Okay, so what's the difference between these two methods? I don't know which one you like better. Do you like it when it says enter a number and then it says 0 to quit? Or do you like it where you enter a number and then later you make the decision whether you're going to continue? Which one feels better to you? Which one? The top one? It's okay if you like the bottom one better, but this one is faster for me. Because you could type in 100 numbers in a row instead of typing in a number, yes, a number, yes, a number, yes. And we could make it faster for them. You know, we could make this Y rather than yes. Another thing that's a problem is that if they type yes lowercase, then it would still fail. So there's a lot we could do to improve it, but I think that's about enough of that. Okay, let's go look and see what's on the next slide, if any. I think what I'm going to do is I'm going to redraw the flowchart to match yep, because that's the last page. To match our modification. So here's our flowchart as is. What's different about it? What's different about our new code? Looking at the code, what's the first change you think I should make to it? I'm going to make a copy and paste of it first. Okay, I don't know if I can bring these up side by side, but I'll give it a shot. Sort of side by side. I'm trying to just do the second one now. So what's wrong with the flowchart if I was updating it to match this logic? Right, and even before that, this initialization. So I'm just going to change that to say R is equal to yes. Why did I use the word R? In my mind, I was thinking, I don't know why. Resume. I should have chosen C for continue, something like that. But anyways, okay. Then the while loop also needs to change. While R is equal to yes. And this flowcharting stuff will be more interesting, although a lot of you will hate it anyways when you're working along with me. Okay, then input my number. And I guess we're assuming that the conversion happens automatically, because that's not even called out in the flowchart. Then what's different? We no longer have an if statement. But we do have an extra input down here. So I'm going to need another box. Now we don't say what R is, so I'm going to make this a two-line box. Print, do you wish to continue? Yes, no. And then input R. Really, I should break those into two separate things. There we go.
In the boxes, do you not have to put like R equals input?
I would prefer to do that, yes. When I flowchart, generally my coding starts to look more and more like Python. So I would be real tempted to do this. R is equal to input, like that. And really I ought to break those up into two boxes, but then this starts looking a little bit too much like Python and not a generic code. Because not everybody is going to use the input command. That language is really Python specific. So is the word print, for a matter of fact, but most people understand what that means. So We're making it match more closely the code at this point, but it's not necessary. The flowchart doesn't have to have a one-to-one correspondence with it. But when I give you a flowchart, it's very likely to have this mode, a print statement followed by an input statement. Or I could make it look exactly like this. I could put that message right inside the input word. I think that's going to be my final answer for this one. All right, that decision block, there's something I want to mention about it. Which is that notice there's a line coming back up to it. The only time that happens is if this is a loop. If this was the word if, it would not have a line coming back to it. Let's go look at that if statement that we had in our previous version of the flowchart. If my number not equal to 0. We didn't put this line coming back there. I guarantee that somebody's going to do that when they're drawing the flowcharts. If it's if, they're going to put the line back up to it. Or if it's while, they're not going to have the line going back to it. You just have to kind of program yourself. The only time it goes back up is if it's looping. So this is not a loop. Well, this part's not a loop. So this one doesn't go back up, but this one is a loop. So it does go back to it. That's another reason why I actually like putting the word while, or if in my decision blocks. Where if you see books, textbooks, they leave the word if and the word while on. I want this to communicate the most information possible without making it more difficult to understand. And it's easier to understand if you see while there, in my opinion, and you see if there, rather than leaving it as a question. Oh, is that an if or a while? Oh, well, there's a line coming to it. I guess it's a while. You know, I'd rather just nail it out as soon as you see it. Okay, so if you look at these, not that you can really see them because the writing is getting too small. Maybe I can put them side by side. Everything except the stop command is shown now. Most of us agreed that we liked this method better, where we let them type in 0, and if it was 0, we exited the loop. But which one has less complex logic? This one, because it doesn't have an if statement in the middle, making things more complicated. So we're kind of going an extra mile to make things easier when we do it this way. It takes longer to flowchart it, takes a little bit longer to program it, but not that much. You know, flowcharting takes like 10 times longer than just writing the code. But you got to learn the flowcharting too in order to teach your brain to think logically about it.
What do you normally do first? Do you normally flowchart and build a program off of that, or do you just go back?
When I was first learning this stuff, I was a total jerk and I wrote the program first and then I drew the flowchart afterwards. But what I will expect you to do is I will give you pseudocode and want you to draw a flowchart from it, or I will give you a flowchart and want you to do pseudocode from it, one of those two, and then later on I will give you pseudocode or a flowchart and ask you to do a program from it. Does that make sense? Okay. If I just give you a programming problem and I don't ask for a flowchart or pseudocode, I ought to tell you that you should, but if you can think it through without those tools, that's okay.
So this is generally like somebody comes to you and says, here's our flowchart for what we want to program.
Exactly,
And then you
right.
just pick what code you know, or
Right, so flowcharts are useful for things like when you're talking with a customer about what's supposed to happen. you know, and if they're, you know, if the person's income falls below a certain rate or whatever, then you can give them a visual map of what the program is going to do, and then y'all can work it out together. You can work out the business logic. It's not like every single time somebody writes a program, they have to do a flowchart first. Especially as you can see that these get quite big. This was like 8 lines of code. Programs can be tens of thousands of lines long. You break those up into modules, and then you can try to flowchart the relationship between the modules. But flowcharting it's good training, but after a while, you won't do it as much. In classes after this class one at this college, you don't do flowcharts afterwards, as far as I know. Certainly not in my classes. So when you go and take C++ or Java or something like that, or scripting, then you won't be doing flowcharts. Just because you're expected to know how to do it, and you can do it on your own if you need to. All right. Why don't we go ahead and turn in our double and our double 2. If you didn't get the second version of the script typed in, I'll print it out for you, because I'm going to paste it in the notes anyways.
What if we already turned in our first double?
That's totally cool. I'd like for you to upload the second version of it as well, but I'm not going to count off if you don't. It's nice for you to have it there so you can download it and look at it again if you wanted to. Who does need a printout? Nobody? We're all good? Alrighty.
So put it under the in class A.
Nope, I haven't made a Dropbox
okay,
for it
alright.
yet, so that kind of...
I'm jumping the gun.
No, it's not that you jumped the gun, it's that I forgot to tell people to wait. I told you to turn it in, and I didn't create the Dropbox for it. Okay, so in uno momento, in class B, now it's there. And if you already uploaded it into in class A, please upload it again. I apologize for that.
Thank you.
So refresh your Dropbox, you'll see in class B.